In class, we defined chemistry as a study of matter and how matter interacts with matter. Now I want to demonstrate visually that definition. To do that, I'm going to reenact an experience of an individual in the mid-1800s. To guide us, we will use the individual's own words.
While reading a textbook of chemistry, I came upon the statement, nitric acid acts upon copper. I was getting tired of reading such absurd stuff, and I was determined to see what this meant. Copper was more or less familiar to me, for copper scents were then in use. I had seen a bottle marked nitric acid on a table in the doctor's office where I was then doing time. I did not know its peculiarities, but the spirit of adventure was upon me. Having nitric acid and copper, I had only one thing to learn, what act upon meant. Then the statement, nitric acid acts upon copper, would be something more than mere words. In the interest of knowledge, I was even willing to sacrifice one of the few copper cents then in my possession. I put one of them on the table, opened the bottle marked nitric acid, poured some of the liquid on the copper, and prepared to make an observation.
Since I know what nitric acid acts upon copper means, I'm going to put my pennies in this 4-liter vacuum flask. Pennies in the 1800s were larger than the pennies we have today, so I'm going to use a few pre-1982 pennies, which total about the same mass and composition of pennies from the 1800s.
I put one of them on the table, opened the bottle marked nitric acid, poured some of the liquid on the copper, and prepared to make an observation. But what was this wonderful thing which I beheld? The scent was already changed, and it was no small change either. A greenish-blue liquid foamed and fumed over the scent and over the table. The air in the neighborhood of the performance became colored dark red. A great cloud arose. This was disagreeable and suffocating. How should I stop this? I tried to get rid of the objectionable mess by picking it up and throwing it out the window. I learned another fact. Nitric acid not only acts upon copper, but it acts upon fingers. The pain led to another unpremeditated experiment. I drew my fingers across my trousers, and another fact was discovered. Nitric acid acts upon trousers. Taking everything into consideration, that was the most impressive experiment, and relatively probably the most costly experiment I have ever performed. It was a revelation to me. It resulted in a desire on my part to learn more about that remarkable kind of action. Plainly, the only way to learn about it was to see its results, to experiment, to work in a laboratory.
To stop the reaction, I'm going to add water to the flask. And fully initiate the aspirator to remove the brownish colored gas, reddish brown gas from the flask. The reddish brown gas is nitrogen dioxide and is a toxic gas. We now see the solution's blue, and we're seeing a second form of copper. This is the copper-2 ion. To see additional forms of copper, we're now going to add ammonia. This ammonia is similar to the ammonia you would find in your house that is used for cleaning. As we add ammonia, we will see that the blue color that's in the solution begins to turn to another color, begins to turn green. The green color is yet another form of copper, a copper complex of the copper 2 ion with the nitrite ion. If we then add additional ammonia, another form of copper will be produced, copper hydroxide. Copper hydroxide is insoluble in water, and so the solution becomes cloudy. And then with the addition of yet more ammonia, another complex of copper is produced, a complex of copper and ammonia, and the solution becomes clear again. This final form of copper is soluble in water. The reenactment is an experience of Ira Remsen. After this experience, Ira Remsen went on to found the Department of Chemistry at Johns Hopkins University and later become the president of Johns Hopkins